You copy the same logging code into every function. You repeat the timing boilerplate everywhere. Every retry loop looks identical. I am Ahas. Today in episode 24, Decorators Deep Dive, you will learn how to write reusable wrappers that transform functions. We will cover basic decorators and how wrapping works under the hood, functools.wraps to preserve function metadata, parameterized decorators, decorators that take arguments, stacking multiple decorators and understanding the order, class-based decorators using the Dundercall pattern and real production patterns, logging, timing, retry, and rate limiting. By the end, you will have a full API rate limiter decorator. Let's go. A decorator is a function that takes a function and returns a new function. Let's understand what happens under the hood. Look at the code. We define a simple decorator called my_decorator. It accepts func as a parameter, the function being decorated. Inside, we define wrapper. This is the new function that replaces the original. Wrapper calls func and adds behavior before and after. We return wrapper, not the result, the function itself. Now we use the @ syntax. At my_decorator above greet is exactly the same as writing greet equals my_decorator open paren greet close paren. That's all a decorator is, syntactic sugar for function wrapping. When you call greet, you are actually calling wrapper. The original greet lives inside wrapper's closure. This is the foundation of every decorator pattern in Python. There's a problem with basic decorators. They destroy metadata. Look at the left side without functools.wraps. We define a basic timer decorator that wraps a function. After applying it, greet.dunderName returns wrapper, not greet. Greet.dunderDoc returns none. The doc string is lost. This breaks help, debugging, introspection, and some frameworks. Now look at the right side with functools.wraps. We import wraps from functools. We added wraps open paren, func, close paren above wrapper. That's the only change. Now greet.dunderName returns greet, correct. Greet.dunderDoc returns the real doc string. Functools.wraps copies name, doc, qual name, module, and annotation from the original function to the wrapper. Always use functools.wraps in every decorator you write. It is one line, and it prevents an entire class of bugs. What if your decorator needs configuration? A parameterized decorator is a function that returns a decorator. You need 3 levels of nesting. Look at the code. We define a repeat decorator that takes a times parameter. Repeat of times returns decorator. Decorator takes func and returns wrapper. Wrapper calls func exactly times. We use it as a repeat open paren 3 close paren above greet. Python evaluates repeat of 3 first, which returns the decorator function. Then that decorator is applied to greet. The result, calling greet runs 3 times. This 3-level pattern, outer takes config, middle takes func, inner is the wrapper, is the standard recipe for every parameterized decorator. You will see this in Flask route, PyDis mark, and click command. You can stack multiple decorators on one function. Order matters. Decorators apply bottom to top. Look at the code. We define a bold decorator that wraps output in B tags. We define an italic decorator that wraps in I tags. When we write at bold above at italic above greet, Python applies italic to greet first, then bold to the result. So the output is bold wrapping italic, B tags outside I tags. The rule: the decorator closest to the function runs first. Think of it as stacking function calls from inside out. At A, at B, def func means func equals A of B of func. This is exactly how Flask stacks route and login_required, or how PyDis stacks mark.parameterize and mark.slow. Remember, read decorator stack from bottom to top to understand execution order. A class can be a decorator too. Use the dunder init and Dundercall pattern. Look at the code. We define a call counter class. Dunder init accepts func and stores it. It also initializes a count attribute to 0. Dundercall makes instances callable. When the decorated function is invoked, Python calls Dundercall instead. Inside Dundercall, we increment count, call func, and return the result. We decorate greet with a call counter. Now greet is a call counter instance. Every time greet is called, count increments. We can inspect greet.count at any time. Class-based decorators are better than function decorators when you need persistent state across calls, like counting invocations, caching results, or throttling. Let's look at 3 production-ready decorator patterns. First, the timer decorator. Import time and functools.wraps. Use perf_counter before and after the call. Print or log the elapsed time. Apply to any function to measure its runtime. Second, the retry decorator. It accepts max_attempts and delay in seconds. Wrap the call in a for loop up to max_attempts. On exception, sleep for delay seconds and try again. After all attempts fail, re-raise the last exception. This pattern handles flaky network calls and database timeouts. Third, the logger decorator. Log the function name, arguments, and return value. Useful for debugging without modifying the function body. All 3 use functools.wraps. All 3 are reusable across any function in your codebase. Python ships with powerful built-in decorators. Let's cover the 4 most important ones. First, at functools.ru_cache. Least recently used cache memoizes function results. The first call computes the result and stores it. Subsequent calls with the same arguments return from cache instantly. You can set max_size to limit cache entries. None means unlimited. Second, at functools.cache. Python 3.9 plus. Same as ru cache with max_size of none. Simpler syntax for unbounded memoization. Third, at static method. Defines a method that does not receive self or CLS. No access to instance or class state. A pure utility function on the class namespace. Fourth, at class method. Receives CLS as the first argument instead of self. Used for alternative constructors and factory methods. These 4 decorators handle caching and method binding. Use them before reaching for third-party solutions. Our mini project, an API rate limiter decorator. This is a pattern used in every production API client. Look at the code. We define a rate_limit decorator accepting calls and period in seconds. It keeps a deque of call timestamps with maxlen equal to calls. In the wrapper, before each call we check. If the deque is full, compute the Windows start. If the oldest call is within the current period, we must wait. We sleep for the required delay. Then we append now to the deque and call the function. We apply at rate_limit with calls equals 5 and period equals 10. This means no more than 5 calls in any 10-second window. The decorator enforces this automatically. The function never knows. This is the decorator pattern at its best. Cross-cutting concerns separated from business logic. Your challenge: build a production decorator toolkit. Step 1. Write a validate_types decorator. Use function annotations to check argument types at call time. Raise type error if any argument does not match its annotation. Use functools.wraps and inspect.signature. Step 2. Write a memoized decorator with a time-to-live argument in seconds. Cached results expire after the TTL. Store timestamps alongside cached values. Step 3. Write a singleton class decorator. Decorate any class and ensure only one instance ever exists. Step 4. Stack validate_types and memoize on one function. Step 5. Run mypy-strict. 0 errors required. Paste your decorator toolkit and mypy output in the comments. I read every single one. Let's recap what you learned today. A decorator is a function that takes a function and returns a new function. @ syntax is sugar for func equals decorator open paren, func close paren. Functools.wraps preserves name, doc, and annotations. Always use it. Parameterized decorators need 3 levels: config, decorator, wrapper. Stacking applies bottom to top. Closest to function runs first. Class decorators use dunder init and dunder call for stateful wrapping. Real patterns: timer, retry, logger, all reusable and composable. Built-ins: ru_cache, cache, static method, class method. The mini project built an API rate limiter with Deque-based windowing. Next episode, async Python, async def, await, essentio, gather, and async context managers. Subscribe so you don't miss it. See you tomorrow. Decorators, mastered. Your Python functions are now wrapped, logged, cached, and rate limited. Subscribe for the next episode. Drop your Decorator toolkit in the comments. I am Ahaz. See you in episode 25.